3.5, solving inequalities. So solving inequalities with variables on both sides. And that's largely true. We do get some of that, but the questions in here aren't limited just to those things. I kind of figured I could break the notes up into two different parts. My first one is just special cases, which is kind of the teacher way of saying weird stuff that I didn't know how to classify it. But so special cases, just want to show you a couple tricks that sometimes you'll see and how to survive them with grace and style. So the first one would be something like 4x minus 7. So 4x minus 7 is greater than x. And we've been messing with ones like that before where we had to first get the variable all on one side of the equation, right? So what do we do to get all the x's together? We could, you could if you wanted to. I wouldn't write this in your notes, but you could subtract 4x from both sides, and that would give us a negative 3x over here, right? And that's totally legit. That's actually maybe a better thing. That just doesn't prove the point I'm trying to prove in this one. Let's say we wanted to move all the x's to the left side instead of that. We have 1x there, right? So we'd subtract x or subtract 1x. So subtract an x. So we'd end up with 3x minus 7. Do we flip the sign? Nope, so we didn't multiply or divide by a negative. Now, what's left on the right-hand side? Go for it, Liam.
A 0.
A 0. Yep, nothing's over there, so it has to be a 0. Does that make sense, everybody? And then from there, we could add 7 to both sides and solve. So actually, the subtracting 4x, you have a negative, but it's one step fewer. But you just don't, I really wanted to point out, if you get rid of everything on a side, it becomes 0 on that side. We good? Okay. So that was one that I thought of. Another one that might come in handy is if we have 4 parentheses 8 minus x parentheses is less than 5x. There's really two options for what you can do first. Does anybody see one of the two? Yeah, one option is to distribute. And then you could then, so let me say, well, if you distribute first, you'd have 32 minus 4x is less than 5x. And then you'd probably add 4x to both sides and kind of go from there. Does this one make sense? Solve it from there. The other option would be to do what Zoe just said, would be to, maybe, how do I want to write this? I'll just do or. The other option, and you could choose to write this, you could choose to not write this, but if you say it's less than 5x, the thing I'm really trying to point out is you can't go through and add x to both sides right now to cancel out what's inside the parentheses. So it's not legal to say plus x, that drops out, plus x, and that we have a 6x on the right. That you can't do that because that x is going to be multiplied by 4 soon. So that's why it doesn't cancel out. The other thing you could do is what Zoe had mentioned, is that we could say, well, because it's 4 times the whole rest of the thing, you could divide by 4 as a first step. And then in doing that, you'd have 4's dropping out, so 8 minus x is less than, we divide it by a positive, so we don't flip the sign. You could say 5/4 x. I kind of like the decimals. I'd probably say 1.25x. Or 5/4 x. So something like that. You basically have to take care of the parentheses before you can mess with stuff inside it. Good for that one too? So those will be tricks that you see. Yesterday we had the notes where I said, here are some things that I found most people just didn't bother with. This is another one of those. That it's a way to make a problem look nicer, but most people don't bother doing the extra step. You just work with the uglier problem. So I'm going to call it nasty decimals. And if you wanted to do the kind of what's the key to fixing ones like these, you could say multiply to get rid of the decimals. So we're going to multiply by some factor of 10. So either by 10 to move the decimal 1 place, 100 to move it 2 places, 10,000 to move the decimal 4 places. My problem with doing that is now I have to deal with like some really big numbers, and I'd rather just deal with the decimals as opposed to like 10,000x plus this equals whatever. But here's the example if you want to at least look at it. So it'd be 4.27x minus 1.2 is less than 24.78. Especially if you're using a calculator, it's really not that bad of a problem to just work with it the way it is. You just have to keep track of the decimals. What the book is saying is a good thing to do is to say, all right, I want to get rid of all those decimals. So I can keep this thing, I don't change the answer, maybe that's the best way to say it, I don't change the answer if I multiply all parts of both sides by some number. So my maximum number of decimals is going to be 2, right? I have 4.27, I have 2 decimal points there. I have 24.78, 2 decimal points there. So if I want to move the decimal point 2 to the right, what do I multiply by? Multiply by a 1 with how many zeros? Yep, 2 zeros. So if I multiply by 100, we have to multiply all parts of this. So we do distributive there on the left. But what that turns it into is 427x minus, so I just move my decimal point 2 places. If I move this decimal point 2 places, I get what? Not 12, but 120. So I have to add the 0 on to show that I took and moved the decimal point 2 jumps to right there. Is less than 2,478. So now in solving that problem, I don't have any decimals, but I'm going to be working with some pretty big numbers. So totally up to you. You could take this original problem with the decimals and just go through and do that one, or you could multiply by it 100 or 10 or 1 million, however many you need to get no decimals left. Feeling okay so far? And then just say, then solve. So once you got it that far, you'd solve it. Move on to the last section. Last section, I'm going to call it Roman numeral 2. This is what happens when you end up with inequality that something weird happens. If you get like 4 is greater than 7 as your answer. And Blake would tell you that 4 is never greater than 7. Even if you say the words in Spanish, 4 is not bigger than 7. So when you have something like that that's not true, you don't get any solutions. So I'm going to call my Roman numeral 2 no solutions, or all real numbers. So the other weird thing that we're going to get sometimes is where anything could work for x. X could be 2, it could be 17, it could be pi, it could be 6.5.3 if that was a number, it could be anything. Okay, so first example would be if I had a x plus 4 is greater than or equal to x minus 8. So if we wanted to solve that one, what could be our first step? Who's going to throw something out there? I think I heard a minus 4. And that would totally work. So those cancel out. I have x is greater than or equal to x minus 12. Next step would be to... Oh. Well, this will still work. If I subtract x, because I have a 1x there, so let's kind of move that x away. So I end up with x minus x gives me 0. Yep, we had something. We took it all away. So 0 is greater than or equal to negative 12. Is 0 greater than or equal to negative 12? Always? Yeah. So does x matter? So is this the no solutions or all real numbers are solutions? Yeah, perfect. So then you could say x, here's where suddenly I'm realizing, how do I write this? X, maybe say x could be any real number. So it could be any real number. So I probably should have just said the solution right in the line, all real numbers. That's probably the best thing. So just all real numbers. Sorry about that. Kind of drew a blank. All real numbers. And if you look back at our original problem, it doesn't matter what you put in for x. That if I try to go through here, it actually would have been a little bit faster even if we'd done the x's right at the beginning. We would have subtracted x as our first step, but that's fine. But x plus 4 is greater than x minus 8. It doesn't matter what you put in for x. Put any number in for both of those x's, it's going to be true. If you have a 7 plus 4 gives you 11 is greater than or equal to 7 minus 8, negative 1. It's always true. So, we good on that one? Then the last one, which by process of elimination is going to be the no solutions. So I'm just going to say if you get, so if we'd gone through and done that last one, something like 4 is greater than or equal to 7. That right there, it's never true. So you get something that's never true, then there is no solutions. Yeah, no solutions. And that's it for this section.